Ready? Hi, I'm Scott Kurz. That's my Americanization of that pronunciation. Our whole family, actually. How's the sound? Is that good? So I'm the speaker. I work for IBM. I co-wrote this presentation with Tim Finelli, also at IBM. He's not here. Disclaimers. Who am I? I was the development team lead for the reference implementation and TCK for JSR 352 Java Batch. Now the maintenance specification lead, now that the spec lead, Chris Vignola, has transitioned on. I'm also the team lead for the WebSphere Compute Grid WebSphere Batch function. Who's Tim Finelli. He was a member of the JSR 352 expert group. He teaches at Clarkson University. He does a lot of work on modernizing batch workloads in the mainframe. So I'm going to mention some concepts of Java Batch, of the JSR. I think you'll find from my presentation that we haven't developed out the whole JSR 352 ecosystem in the way that some reference implementations do at this stage. Say, we didn't leverage the spec community into a reference implementation community. So there's a lot of opportunity for that ecosystem to develop. I hope to explain some of the concepts in the JSR and inspire you to go ahead and create some of that integration for all the frameworks out there. I'm going to include a couple demos, a couple thoughts on what I see as the next step. Again, this is maybe a little spec facing, maybe more than your typical presentation, but I think you'll find it interesting. So what is batch? At IBM, we have a long history of batch. The original business computing workloads submitted through punch cards, from before we were all born, or a lot of us were even born. Wikipedia says it best. So I know that there's a short story of the JSR 352, which is that we standardize Spring Batch. And I'm sure a lot of you are familiar with Spring Batch and have worked with Spring Batch. It is true that superficially the main APIs and constructs are indeed very similar to the Spring Batch. We did actually add some from the Compute Grid WebSphere Java Batch function. It's part of WebSphere Application Server version 8.5. That function actually provided, more or less a one-to-one functional equivalence with the key Spring Batch constructs. We did add a couple things into the JSR, more specifically from the Compute Grid heritage, the partition step function details. But we have a long history not only of Java Batch, not only of Batch in general, but of Java Batch. The Compute Grid product is almost 10 years old, and we find it a very important part of the WebSphere strategy. So we were happy to work with Spring Batch and others to standardize this API in Java, and so we did. So the expert group formed in November 2011. I wasn't originally a part of it. You see the members, VMware representing Spring Batch. We had a final release in May 2013, and it is part of EE7. I will say the JSR work did a number on me. I was originally looking like this guy over here before I started in the JSR, and they're actually thinking of having me do this shot, but put on a few pounds working on the JSR. I'm hoping to be there for DevOps 2014. Thanks for your support. It's probably these pants. They make me look slim. My wife said that they're my most flattering pants. So although the JSR only adds batch to the EE platform, it doesn't add it to to any SE platform. It is SE friendly. I mean, we do, except for the transactional requirement, we do expect these functions to work, in an SE environment as well. So of course we have the reference implementation. We have the source out there on java.net in our JBatch java.net project, but we don't accept any contributions. We structured the project that way right from the start, for better or for worse. And it's a spec-focused project. We're advancing the spec. We're not, like I said, integrating with other technologies. And we're lagging even a bit on bug fixes. So I just want to set the expectations on the reference implementation. Of course, Spring Batch is working on an implementation as well. Red Hat is too. I keep forgetting their product name. Is it JBeret? Does anyone know? Might not even be announced. Maybe I shouldn't even have said that. I obviously don't speak for Red Hat. Also, we learned recently that there's been an Apache project that started by forking the reference implementation. It's the Batch EE project, which I linked to at the end. I assume it has some association with Tom EE, but I don't really know. I'm not sure. At this point, we're not actively participating in the project. We are interested. Anyone else? Any other implementations to mention? So, with all the big data presentations, which also throw the word batch into the titles or descriptions, I thought maybe I'd just touch on how Java batch, transactional batch might fit into that picture. And the key is, I think, transactional batch. You're not going to want to process, billions of data points necessarily, each in a transaction. It's not necessary. On the other hand, if you're processing 1 million tax returns, say, obviously transactions are important. The logic might even be similar to an online function, but without the requirement for a quick response time, the efficiency gained by grouping them into a batch becomes compelling. One thing we did learn from working in the expert group is that people were using batch in ways that we hadn't been used to dealing with. At IBM, I'm sure people are using things like Hadoop in ways that I'm not familiar with either. So, I'm not intending to be the final word on the subject, but maybe that's a good framework for starting to look at this in. Okay, so one key concept in batch in the JSR is the definition of a job versus a job instance versus a job execution. So I define my job in an XML file. And when I submit it, when I start it for the first time, I create a job instance. And on that first start, I also create the first job execution. That execution may run to completion, or it may fail, in which case I need to restart it and thereby create a second job execution for that same job instance. So if we look at this example from the spec, we have the end of day job defined once in XML, submitted each day. The first time it's submitted, you create the first job execution, but if it doesn't complete, like I said, you can restart it and create multiple executions associated with that same instance. So that's a key concept. So batch is built with a couple facilities for facilitating restart, for being able to pick up where you left off. Maybe the data was invalid. Maybe someone else's program was at fault. Maybe you just got locked out of some data you needed. Or another case we see is your workload prioritization changes. Your batch window no longer takes priority, and you want to stop the job and pick it up at a later point. So there's two main facilities for a restart. Within the job, you by default will not rerun an already completed step. You'll pick up where you left off. And within the set, the processing model, within the step, with the processing model has these checkpoints which allow you to pick up in the data set where you left off. So a key concept as well is the chunk loop. I think this originally came from the Spring Batch documentation. There are three constructs in the chunk step, the most important ones: the item reader, the item processor, the item writer. And the flow is read, process, etc. until we decide it's the end of the chunk. The container decides the chunk is ready to be written, in which case all the items, all the processed items are written in a batch. And that's all performed, at least in EE, in a global transaction, and that coordinates the persistence of the latest checkpoint value with the data actually being read and written here. And this this chunk loop repeats over and over until the reader says there's no more data, and there the step ends. And for what it's worth, I understand that Spring Batch may actually function just a bit differently here, pretty similar, but I won't say exactly how because I'm not sure, but kind of close. And interestingly enough, in WebSphere Batch, WebSphere Compute Grid, we accomplish essentially the same goal in giving you the checkpoint of readers and writers, but we kind of flip this all on its head. We have a single loop that's more like a process, and you just return either continue or I'm done. And then we offer a checkpointed reader-writer API that you can use in more or less a free-form manner. So moving to the JSR programming model is a constraint on the WebSphere programming model. But working in the expert group, we realized that was all our applications really needed. They could definitely structure themselves through a single reader, processor, writer. And so we were happy to go with the more like the Spring Batch approach. So you can look at the entire JSR and single out three key roles. The implementer actually writing the batch artifacts, the reader to read from a text file or whatever data stream, the processor, the writer, etc. Then you could find the orchestrator. That would be the person who assembles these artifacts into step definitions and assembles those steps into a sequence and thereby defines a job. Besides the orchestrator and the implementer, there's also this third role. That is the person that actually executes the job, starts the job. Maybe in the case of the closing batch window I mentioned, stops the job, has some logic for deciding whether and when to restart the job. So you can look at these three roles, and they're not new roles. This fits into existing paradigms, and I'll try to show the various functions fitting into one of those three. Yeah, and here's a high-level view of basically what I just said. So what are the key implementation constructs of what's a programming model? We have two types of steps, the chunk and batchlet. The chunk you already saw in the chunk loop. We have context so that artifacts can share data within a step and even across steps within the job. We have a whole bunch of listeners defined, providing callbacks on various lifecycle events. And we also have this partitioning mechanism that we define, that we take from WebSphere Batch, which we'll also see in some detail here. Again, the chunk provides an ETL pattern, extract, transform, load, whereas the batch is free form. It's just a single call, and you can do whatever you want in it. Here's an example single step job, and you can see it's a chunk step defining a reader, processor, writer, referring to those artifacts with that ref attribute and parameterizing it with that property. It's about as simple as it gets. And then, in terms of execution, we provide a single execution interface, the job operator. The first method you'd use is start a job. That everything else, is downstream from that. And you can think of this job repository, although it's not actually a class, it doesn't expose any methods of itself. You can think of it as holding the information persisted from the earlier job executions. What step the execution reached, what were the various checkpoint values, other metrics. And to start a batch job, you basically just pass it a reference to the JSL. And I don't know I think I mentioned it, but the JSL stands for Job Specification Language. It is the XML, like in the last slide example. And, we sort of view it as a similar acronym to JCL, Job Control Language, which has, been around for many years in IBM Batch. So we see a heritage there, and the idea of jobs and steps, et cetera. Okay, so the reader, again, we expect, I know Spring Batch has a whole library, at least in their pre-JSR product. I'm sure they're working on the JSR versions. WebSphere Batch has a library as well. We expect wide variety of readers to become available, and they all provide some kind of checkpoint function to position the reader, within the data set. So here's a reader that I kind of cut out all irrelevant code and just tried to pin down the essentials. You can see it's responsible not only for reading, but for positioning based on the container managed, the container persisted checkpoint so that it can resume execution within the step where it left off. So the checkpoint is managed through this num records processed counter, and you can see that the first call here would be to the last method, actually the open. First time when it's past the null checkpoint, it just initializes that value to 0. And when it's called with a non-null value, that would be on a restart. And it would simply initialize that counter to the checkpoint value passed to it by the container. And then what does it do? It advances the cursor in this for loop, thereby positioning itself. So it's fairly simple. Another part of this is the the checkpoint info method, where it simply returns that counter to the container when asked. So that would typically be at the end of the chunk when the container is looking to advance the checkpoint and persist the application provided value. To the container, this is an opaque value. The container has no idea what the reader is going to do with this value, but it's responsible for persisting it. You don't see any logic in the reader, worrying about persistence. The read method, not only does it read a line from the reader here, but it advances the cursor as well. So that's the reader, the checkpointed reader in a nutshell. Pretty simple. Here's a writer example. It's a little blurry. One difference is, as I showed you in the chunk loop, you write all the items at the end of the read process loop. You write the whole chunk. And, sometimes, I'm not sure if this is, in a case like this, the writer doesn't actually even need to position. It's a little blurry, so I can't see it. I know in my demo, which I'm going to show you shortly, there really is no positioning. The writer just, persists the data to the database. So positioning isn't a feature of every reader and writer. So in the bottom right is another, I think it's the same JSL example as before. Here I'm going to show you another artifact, the XML file. The mapping between the ref attribute value in the JSL and an actual Java class, the actual instance of one of these reader, processor, writer, or whatever artifacts, it's actually not standard. An implementation is welcome to define its own mechanism here. But the spec does define a default, which is to use this batch XML side file, which you can see is simple mapping of ref value to class name. In the reference implementation, we actually use something else, which I'll show you in a bit. I'm going to skip over the execution. So let's look at the demo. So this is a two-step job. Step one is going to generate some random integer data and dump it into a text file. Step two is going to read one line at a time, perform a simple math calculation on that integer, and write some output plus some accompanying data just to make the demo a little more interesting into a database table. This isn't really a demo feature, but one thing I didn't really mention, one of the key uses of this checkpoint value and the reason for moving it, delegating the responsibility off to the designer, is that the checkpoint defines the transaction size, and that's going to come into play when you have lock contention and you decide, well, we're holding locks for too long. We need to maybe lose some efficiency and checkpoint more frequently, or vice versa. Okay, so let's get to the demo. Okay, so max index, there's currently nothing in the database. Oh boy. Okay, so you can see I ran through the generate step in no time at all. Another thing you see up here is the current batch status of the job. Java batch defines a few states through Java enum, and there's only a few of them. Started means it's actually running. And now the batch status has failed. The reason it's failed is because to make the demo interesting and to show you a restart, I threw a timeout in there to just blow up in the middle of the demo. So you can see it executed for about 1 second, and it got through 200 records. There's actually 2 counts here of 200, and the reason is that the demo app uses the job operator's metrics API to show how many records it's written. And then I also did a direct query of the database to prove that the metrics function was working. So yeah, 200 records. So let's restart this job, and I'll give it a little longer. I haven't done this demo a lot, but every time I do it, it seems to slow down, get slower and slower. Is that a Windows thing? I think in my nerves, I just blew through that last execution without stopping to talk. Okay, so regardless of what I did before. So one thing you see on the restart, I actually did 2 restarts just now, not just the one. The first step, generate step, did not run. Like I said, you pick up in the job where you left off. We ran for 5 seconds in step 2 in this job execution. That also is provided by a job operator metrics API. We ran through 2,500 records in this last execution, as the metrics API shows. And from the database, it shows we're up to 4,200 altogether. So we need to get through 10,000. I better bump this up to 15 seconds. And I think this time we'll get there. Take a drink. This is a groundbreaking demo app here. All right, we get to see the blue completed, the universal color for completed blue. We got 10,000 records. This actually shows the math calculation. It's something like the biggest divisor less than the square root or something. I didn't know the mathematical term. I called it big divisor, but it seemed somewhat like it was making the app do something. I show the, no, I don't even know what records I'm showing here. The original execution timestamp, though, is interesting as we look at the app because it shows that we are actually able to persist some data in the app with the help of the container and then reconstitute it on these restart executions. So the fact that 10,000, record 10,001 have the same value across the different executions shows this persisted data. And you can't argue with the math either. Okay, so let's just kind of take a quick look at some of these application artifacts real quick. Okay, so this is the first thing I want to show you. The start job. You simply get the job operator through a static factory, and we pass this start method the name of actually the JSL file, and that mapping of the start value to the actual job definition is also implementation specific, but there's a default mapping which is simply the file name, and you can also parameterize the job through a properties object that you pass from the job operator client, which we see here. We have the timeout that actually was passed through from the web form that I was tweaking. Let's look at the JSL, the sample analysis XML, and if you look at how my XML files are all over the place, you can see this crying out for some kind of Maven or other organization, because At the point when I did this demo, these files are just all over the place. Okay, here's the sample analysis XML. You can see that if we just look at the steps and the step flow, we have the generate data step with a next attribute pointing to the second step, the analyze data. We also can see some properties set. Let's look at the batchlet, the first step. We see the first two properties set as simple literal values. And then we see the third property set with a different syntax. This is a substitution that is resolved by a containing scope. So this data file name, this job properties bracket data file name refers to the data file name property defined in this containing scope as a child of the job element, as opposed to here we're in the batchlet properties element. So that's one form of substitution, and we'll look at others. And if we look at the batchlet, we'll see those properties injected with this syntax here. Okay. Currently in 1.0, these are all string properties, and a process method is pretty straightforward, not that interesting. So we looked, let's go back to the XML and look a bit at the second step. This one defines a chunk listener, which is just one of the variety of listeners, the only one I show in my demo. Defines a chunk in terms of the reader, processor, writer mentioned. This uses another two substitutions for its two properties. These are actually both properties of the reader. One is the analyze timeout, and this is a different substitution syntax. It's another flavor. This one comes from the job operator client, from the first Java file, the batch client file I showed. And the second one, is actually very similar to the first step's data file name. It's a convenient syntax to let you substitute, from a higher level within the job to various lower levels. So if we look at the processor, actually, next thing I want to show you is the chunk listener. So this shows the two things. The injection of the step context, which is going to be an instance shared by all artifacts within the step, and also the persistent data. So, the very first time we call this, it's going to be null, and we're going to set that initial value, and then we never set it again, which is why in the table on the web app you see the same value there. The processor, this is the business logic, in our case the math computation. Not much interesting there. We do set the timestamp we mentioned from the last step. Also, this shows a really simple integration with CDI, at least in the EE environment. I don't think I mentioned yet, but the specific dependency injected framework is not specified by JSR 352. We've used CDI as an obvious choice in EE, but we're using the inject API, which allows for other implementations as well. So this managed signature is something I defined elsewhere in the demo. One more correspondence I want to show you. This is also something not defined in the spec, but if we look at this processor element in this ref value of capital P processor, we'll see it actually aligns with the named attribute value here. So what we're doing the RI is we're using the CDI bean name as a simple way to resolve the ref value. I don't know if there's other technologies doing that. I mean, it's not exactly groundbreaking, but it certainly seems simpler than having to keep that side file if you already have some bean names. So we went with that, even though it's not standard. If we look at the writer then, the processor, by the way, creates this numerical record, which is a JPA object. If we look at the writer then, you'll see this really couldn't get less application specific. I mean, this JPA writer could be used for almost anything. The only thing that's at all application specific is the bean name and the persistence unit name. And that speaks to the fact that there's a lot of repetition in batch applications. If you're reading a text file or just running through the same query through a million database records, your one app's going to look pretty similar to your other app. And the various libraries, the WebSphere batch, and I know Spring has a bunch of libraries, they address this by providing their own function here for you to reuse. And I think the Batch EE project, the Apache project that I mentioned earlier, I think they're working on that as well, which is pretty interesting. Okay, so that's all for this round. If we look at some other features, the job designer can define in the JSL that certain exceptions are skippable. Depending on it's typed on application exception class. Certain exceptions can also be declared to be retried. So you would either retry the chunk or even retry that single item. And there's limits too. I only want to tolerate 3 skips. There's include exclude. I want this all SQL exception except this one or something along those lines. This and this sub exception of SQL exception, say. And obviously, since it's in the JSL, there's no application exception handling code needed for that. It's all done independently in the JSL. So my demo app doesn't do anything that's complicated, but I have to mention that we can do conditional transitioning from the JSL, or return code based transitioning. We have even a simple glob syntax, pattern matching. So you can transition to one step versus another, or even fail or end or stop the job completely, depending on certain return codes. Those return codes are what we call the exit status. It's a string value in batch, and can be useful. Although a lot of times you're simply, transitioning step 1, step 2, step 3, and maybe failing if something wrong happens. But it is possible. I already touched on the fact that Java operator exposes a stop method. One thing we don't specify in any way in the JSR is any other integration from outside the job management. In WebSphere Batch, we certainly integrate the external scheduler into the management of the Java Batch job, but that's up to the implementation. We don't really say anything about that. And of course, one of the whole points of putting this in EE is to get access to the whole EE platform. One thing I just kind of flew by real quick in the beginning because I don't think I need to sell this crowd on the merits of Java as a programming language compared to, say, COBOL, if anyone knows any COBOL. But in IBM, it's actually a case we make on a regular basis. And besides the modern, the skills, the tool sets, we also have a lot of interesting things going on in the JVM. We've optimized workloads to go 10 times as fast through iterating the JVM and even the mainframe hardware. So we're doing this Java mainframe batch comparison, and then a few years later, the Java is 10 times faster. So it's pretty neat. One area of personal interest to me is the dump diagnostics, and I don't really have any excuse to say anything about that in this presentation. I'm not going to sort through a dump, but I know IBM at least has done some pretty interesting stuff in providing various frameworks for poking through memory and Java dumps, and it's pretty exciting. So Java Batch JSR 352 also offers a couple of parallel mechanisms. Splits and flows are constructs that we took from Spring Batch. We didn't have that in WebSphere Batch. It allows two unrelated steps or collections of steps to run sequentially. It's not necessarily the same logic, but they can be running side by side. And then we also have step-level parallelism or partitioning, in which case the same logic runs against subsets of the same original data set. And we define various constructs for dividing that up and merging the results. The division you can see here, it can either be more defined in the JSL, or it can also be determined programmatically through the partition mapper. And just to show you an example, of how easy this can be, I'm going to take that same app, same demo app, redeploy it. I'm running in Glassfish 4, by the way. I don't know if I mentioned that. Okay, I think that worked. Okay, I'm going to check this convenient checkbox to run partition mode. Started, failed. This is a bug, this metric set to 0. We actually processed 1,000 records across all the partitions. Let's look at the JSL for the partition job. Oh, you know what? I forgot a step here. Well, I cheated. I'm running off the data from the last time I ran the job. So since I didn't partition in step 1, I'd just done the Unix split command on the data from a previous run, and I have 3 old data sets that I'm working from, which is fine. So if we look at the syntax here, the reader syntax is basically identical, except for the data file name, which which points to a partition-specific value. And that partition-specific value is defined down here in what may be a bit verbose syntax. This is looking a little unwieldy. This is the way to do it. These data files are the file names that I split the data into with the split command. So you've got a compound substitution here, the two back to back. And so each partition is going to get, the partition 0, 1, and 2 is going to get the files 0, 1, and 2. Interesting to note, there's no other change to the Java in this particular application, in order to run it in partition mode. It's done entirely through the JSL, which is pretty nice because it says that you don't necessarily have to know ahead of time whether you want something to be partitioned or not. That's not always going to be the case. There are cases where you do need to coordinate among the partitions, and we provide APIs for that, but it is an option. So I got through 1,000. I'm going to bump this up to 5,000. I'm not a real web app guy. This is the most advanced GUI web app I've ever written, and I actually had a lot of fun with it. That just shows you how exciting my regular job is. the last time I did anything with web apps, it was with JSPs, and I just found it so painful. And I just picked up JSF, and I didn't even read any documentation. It just kind of seemed to intuitively work the way I thought. And it was so good, I started telling my team about it. Next time you do something, try JSF. It's a lot better than JSP. And I was so excited about it that I just pictured, this other guy saying, but this and this about JSF. So I don't know why, but I just went and Googled, JSF sucks. And of course, I found this whole long write-up of, all the crappy things about JSF. And it's just funny how we're like that. I mean, there's 5,000 web frameworks. If JSF doesn't fit your needs, then, use one of those other 5,000. Does it have to suck? I don't know. So anyway, we got through all 10,000 in spite of that broken metric. At least the timestamps show you this is a live demo at 4:13 in the morning. So this actually shows something which is a bit, well, I think I'm going to touch on it a bit more, but I mean, you do see some interleaving here, right? I mean, to get through these 10,000 records, and by the way, we started at record 10,000 since we're using the same database as the first demo. So we're going from 10 to 20,000. The first three on the first thread are certainly interleaved with the first three on the other two threads. And, the same as we look towards the end of the execution. The last three on each thread are all in the 19,900 range. Also, we see that there are three distinct timestamps. And what that shows is that persistent data associated with the step context is a per partition persistent data. So it's kind of like a thread local in some ways, although it's actually not quite a thread local because the thread associated with partition 0 may not be the same across executions. You're going to the thread pool a new time, and there's no need to give you that same thread. But the partition itself is going to have some data, and that it's important to know as you're designing your application. Okay, that's it for the demo. Like I said, it's not necessarily the general case that there's zero change to go from a non-partition to a partition step. You might need to coalesce or sum up the exit status, the return code, do that with the partition analyzer. You might need to make intermediate calculations from the partition thread on the main thread, and we have the collector analyzer flow for that. You might need to do other coordinations on the end of the partition, and you might want to programmatically map out the property values, and that includes the number of partitions. I had 3 partitions defined in the JSL statically, but that number itself can be calculated programmatically if your app has use for that. So, I didn't have much in the way of best practices, but in terms of just some things that maybe are a little surprising as you pick up this new programming model, like I said, the job context and step context, have this sort of thread local or partition local nature, and one consequence of that is that I can't simply set some data into the job context in step 1 and expect it to be there in step 2 if I'm using a partition step. Each partition is going to get its own copy, not only of step context, as we used in my demo app, but of job context even. And you have to design the application accordingly. That might seem a little surprising and unuseful, and you have to keep in mind though that this design allows for partitions to be farmed out to different JVMs in a cluster, and so that was purposely designed accordingly. If we come up with a standard pattern for addressing this, on the other hand, maybe we'd consider that in the future. And also, you have to be careful with transient data too, because of course, in a restart, you're not necessarily going to have run through the same steps within the job. So keep that in mind. I didn't mention, but this idea of I only need to run the steps that I haven't completed yet, that is the default behavior, but you can certainly design the job differently. There's an attribute on the step called allow start if complete, and the default's false, but if you set it to true, then you will run that job again on execution, on re-execution, on restart. You might have a job where you have to go FTP the latest files every time, even on a restart, and that's small compared to what you're going to do with that data. So you can certainly design your jobs like that. I would sort of encourage you not to go read the spec description of the exact restart behavior, because this exact calculation of how to know when to rerun a step or not and what exactly runs kind of gets a little complicated, and it's probably more trouble than it's worth to start there. So be warned. I already touched on this, but again, this use of CDI is sort of implementation specific. It was actually a challenge working on the spec, wanting to fit into EE and be part of EE7 and integrate with CDI when possible, and yet still not take too firm a line in requiring CDI. And it's a bit of a subtlety here, but we think we're in the right place. Typically, the beans XML will be the trigger to kick off CDI, instantiation, dependency resolution, etc. As a consequence of that, the batch implementation has to be able to satisfy those injections, the injection of the context and the properties through CDI. I know probably too many of you are not going to be writing implementations, you're going to be writing applications and maybe other pieces of this ecosystem, so maybe that's not so much of general interest. But we actually solved that problem by writing a CDI extension in the reference implementation for that. So where are we in the spec? What's next? We found a few gray areas in the spec and going through the TCK and hearing some challenges, and I'd like to get an update out there by the end of the year. I also think we should look at a 1.1. We have a couple kind of minor features that should be non-controversial, like injecting other types of properties like an integer, so you don't have to do boilerplate property conversion. Also, some other features. We have JSR 236, the concurrency spec, that's the name of it, in E7 as well. But when we started work on 352, we didn't assume that was going to be there because it was 2011. So there's some things we could standardize and put down as firm requirements. Things as simple as propagating the JNDI namespace and the EE and maybe the class loader, which are, I think, more or less how the RI works today. Kind of realized I wasn't 100% sure. But that would certainly help portability in an EE environment. We didn't give any thought to what the CDI scope should be. I'm not even going to lay out one alternative versus another, but just to sort of recognize, I know there's scopes in CDI, and potentially that could be interesting, and we haven't really gotten there. I think the Batch EE project, the Apache project, might have started to think about that. I saw something on their website last night which suggested they had. One obvious feature that Java programmers would maybe expect in given the context where all these XML files have been replaced by annotations, why do we require the XML? Why don't we have an annotation-based job definition? So I actually wasn't part of the expert group, so I didn't get to hear all these discussions, but I know it was considered and rejected. I'd be interested to talk about that more as we go forward. I mean, as a tester, demo app writer, I can certainly see the value of not having an extra artifact to tag along. But yeah, that is where we ended up on that. This is a blank slate. This is a TBD, but there's certainly, like I've been saying, lots of opportunities for adding to this ecosystem. I'm not that familiar with Spring Batch's ecosystem, so I don't mean to slight them by not talking about it, because I know there is one. But I'm also, like I said, very interested in the Apache Batch project. I actually was expecting to say here, yeah, they forked the RI, watch this space. And last night I saw they had some decent work done, it looked like. I'm drawing a blank on the specifics, but yeah, I've got the link there for you to check out if you're interested. Again, the JBatch mailing list, or the Java.net project, it's very spec focused. I mean, we don't have such an overwhelming volume that we will turn down someone with just a user question. We certainly welcome that, and if it gets to the point where it's too much and distracting from the spec, maybe we'd start a new list, or who knows. But I just want to set the expectation, and I will put this demo up for download before I leave here today. I know you're all very excited, especially with my JSF advocacy there, to see it for yourself. I whipped it up in Maven, but like I said, I need a Maven plugin or something for that, which I'm not skilled enough to write. So some final thoughts. Batch, nothing new under the sun except everything that's been developed in Java for the past 20 years. Are there any questions? So the question is, the spec doesn't say anything about clustering? No, it certainly doesn't say anything about clustering. Is there a more specific feature you were thinking about? So when you talk about clustering, are you talking about the example I mentioned, partitions within a step? Or are you talking more about the job operator client to executing the job? Glassfish high availability configuration? There's no, so I'm not sure if this is the question you're asking, but I'll ask the question I can think of. When you talk about the person, the job operator client, the code starting the job, and you look at that compared to the implementation where the artifacts are actually executing the read process write loop, there's no support for farming that call out across the cluster. It would all be local, if that might be what you're asking. Any other questions? It's kind of bright here. Yep. Are there any plans for integration with known schedulers in future? I heard the part about integration. With what was it? With schedulers. Like, for example, schedulers. So it hasn't come up in the spec community. IBM is very interested in that. Whether we'd be interested in the spec community, in the spec sense, I can't say. I mean, I'd need to hear more demand from different people, or with some rationale for why that would benefit from a standard. We certainly value it though from a product specific point of view, and that's a key feature of WebSphere Batch today with our existing programming model pre-JSR. And is that no, just a hand raise. Question?
If you are using transactions, where in your reader and in your writer is the commit happening?
Okay, good question. The question is if you're using transactions, where in the reader, processor, writer loop is the commit happening? The answer is after the write. So before the first read, it's basically around a chunk. The container manages a transaction around the chunk. So, the very first thing you could think of as doing is, after it starts to trend, is reading the persisted checkpoint, from the database. I guess that would only apply for restart. Doing the read process loop, writing the chunk of the items. Somewhere in there, it's got to get the updated cursor values, the updated checkpoints, persist that into the database, and then commit the whole thing. So that's probably an overly complicated description, but the key point is that the whole read process write loop, along with the updating of the checkpoints, is done in one transaction. Any other questions? I don't see any. Call out if I don't hear you. All right, well, thank you very much. Thanks to Devox for having me.